In this video, we're going to be taking a look at an AP free response question, number 6, from the 2016 AP Calculus AB exam. In this question, we're given a table of values for f, f prime, g, and g prime. Let's read the prompt and see if we can answer parts A, B, and C. So it says the functions f and g have continuous second derivatives. The table above gives values of the functions and their derivatives at selected values of x. Let's focus on the first part, part A. So here it says let k of x equal f of g of x. So we have a composition of functions here on the right-hand side of the equal sign. We want to write an equation for the line tangent to the graph of k at x is equal to 3. To write the equation of the line tangent to a graph, we need a point. We already know the x. And then we also need a slope. Because this is a tangent line to the graph, we need the slope of the tangent line, which is the derivative, or k prime, at 3. That'll go here. Let's figure out the corresponding y value for the given x value of 3. To do that, we don't need the derivative. We just want to evaluate the function for an x value of 3. We're going to go inside the parentheses first and figure out what g of 3 is. So g of 3 is right here. G of 3 is 6. So we'll have f of 6. And then f of 6 is right here, which is 4. So we now know that the corresponding output when the input is 3 happens to be 4. There's your y value for the point. For the slope, we do need to figure out the derivative of k first, and then we'll evaluate that derivative at 3. We need to use the chain rule here because we have a composition of functions. So the chain rule says take the derivative of the outer function, leave the inner function the same, multiply by the derivative of the inner function. Then we'll take that derivative and evaluate it when x is equal to 3. So we'll have g of 3 here on the inside times g prime of 3. To do this, we'll need to figure out what g at 3 is. And before we said that was 6. And then we can also figure out g prime of 3. So if we look at the table, g prime of 3 is equal to 2. So we'll replace that down here. G prime of 3 is 2. We'll also need to know what f prime at 6 is, and f prime is this column right here. So f prime at 6 happens to be 5. When we multiply 5 times 2, we get 10, and that's the value that's going to go here. If you stop there, you might earn a few points for this problem, but you actually haven't answered the question. Sometimes I like to go back and read the question itself to see what I'm supposed to do for my answer. So this says write an equation for the line tangent to the graph. I think point slope is going to be the easiest here, so we'll do y minus the y value, which was 4, is equal to the slope times x minus the x value, which is 3. Some alternate forms of this answer, oftentimes you'll see the 4 added to each side. And then if you wanted to change this into slope-intercept, you could distribute the 10, and then you could do negative 30 plus 4 to get negative 36. I wouldn't do either of those two. I would just stop right here at the boxed-in answer. Grading for this, you're going to get 2 points for finding 10 right here. So this gets you plus 2 points. Writing the equation of the tangent line will get you plus 1. So this one's a 3-point question. Each part happens to be 3 points for this particular AP free response question. Let's move on to part B. Part B says let h of x equal g of x divided by f of x. Our goal is to find h prime at 1. To do that, we're going to use the expression for h, which is g over f. And when we want to find the derivative of that, we need to use the quotient rule. To use the quotient rule, there's a little saying you can use. It's low d high minus high d low, square the bottom, and away we go. So low would be f of x times d high. That's the derivative of the numerator. So low d high minus high d low, that would be the derivative of the denominator, square the bottom, and away we go. We don't need the derivative there, we just want f of x, and we want to square it. Now we want to evaluate this when x is 1. So we'll write h prime at 1 is equal to f at 1 times g prime at 1 minus g at 1 times f prime at 1 all over f at 1 squared. We'll look at the table for some of these values now. We'll actually need to know f, f prime, g, and g prime. And the x value here is 1. So that's going to be this top row right here. All of your values are right here. So it looks like f is -6. So we'll write -6 here. And in the denominator, we can write -6 squared. Oops, used a bracket there. We need g prime at 1 now. So g prime at 1 happens to be 8. And then we need to do minus g at 1 times f prime at 1. So g at 1 is 2. And then we need f prime at 1. F prime at 1 is 3. At this point on the AP exam, I would stop. You don't need to simplify a numerical answer. We've gotten all the variables and the function notation out, so you're good to go. If you did simplify this, let's say it was a multiple choice question, you would get -48 minus 6 over 36. That's -54 over 36. Both -54 and 36 are divisible by 18. -54 divided by 18 is -3. And 36 divided by 18 is 2. So the fully simplified numerical answer is -3 over 2. Once again, don't do that on the AP exam. If you make a mistake, they'll count your mistake as the answer and it'll be wrong. You'll also waste a little bit of time trying to simplify your numerical response. You're done when the variables are gone. We're now going to try part C. Part C involves an integral. We want to evaluate this integral from 1 to 3, and it's of f double prime of 2x. It's not always necessary to use u substitution, but if you'd like, you can use u being equal to 2x for this one. If we take the derivative of each side with respect to x, du dx is equal to 2. The derivative of 2x is 2. If we multiply by dx and divide by 2, we wind up with du over 2 is equal to dx. What I'm going to do is I'm going to substitute that into my expression for the integrand, which is f double prime of 2x, while we're making that u. And then dx is equal to du over 2. So I can take the dx out and replace it with du over 2. We also need to take care of our upper limit. To do that, what we're going to do is use our u expression right here, and we're going to just substitute the x value in for each upper and lower limit here. So 2 times 3 is 6. So in terms of u, the upper limit is 6. 2 times 1 is 2. So in terms of the lower limit in our expression here for the integral, the lower limit needs to be 2. I'm going to debox that. It's not our final answer, but it will help us identify some things that will help us in the problem. Now what we're going to do is we're going to take the antiderivative of this piece right here. The antiderivative of the second derivative is the first derivative. And we want to evaluate that first derivative when u is 2 and when u is 6. We'll go from 6 to 2. Also, I almost forgot about this 2 right here, which is in the denominator. So what I'm going to do for that one is I'm just going to bring that out to the front. It's a coefficient and it's a constant. It's just 1/2. So I'm allowed to do that. I'm allowed to bring that out to the front. Now to evaluate this, we'll evaluate f prime of u at 6 minus f prime evaluated at 2. So here's how I'll write that expression. F prime at 6 minus f prime at 2. It's your fundamental theorem of calculus right there. And if I continue this here, and I need to get my numerical answer, I need f prime at 6 and f prime at 2. So going back to the table, f prime at 6 is 5 minus f prime at 2. And if we look at the table, f prime at 2 is -2. I would leave this answer on the AP exam and call it good. It's a numerical answer. It's fine. If you did simplify it, you'd have 1/2 times 5 minus -2, which is 7. So that would get you 7/2 as a simplified numerical answer.